This video is going to look at some examples dealing with trig functions, and in particular here we're going to look at some examples where we're not necessarily dealing with the unit circle, so that we're going to have a different radius, so we're going to have to be able to calculate that radius in order to determine the 6 trig functions. So here we have the given directions. It says the given point is on the terminal side of an angle in standard position. We want to determine the exact values of the given trig functions of the angle. So here is our given point of 4, 5. And here we want to now calculate the sine function of the location of this particular coordinate. Well, I always think it's helpful here to draw a picture, so I'm actually going to sketch out where this point is located. We know it's 4 or 5. The x and y are both positive, so we know the point's going to be in the first quadrant. So if we were to go over 4 units and then up 5, so here's our point, okay? And then we can think here's the radius particular, so here's the angle theta that we're trying to find the sine function of. Okay, so then if we're going to calculate this, then we know that if we think of this as our x is 4, our y is 5, and just like we did earlier, you can kind of think of this as if we draw this straight line down here from our point, we can think of this as a right triangle, and basically what we're saying is we have here, this side is 4, this side is 5, and we need to find the hypotenuse. So we can certainly use our Pythagorean theorem, which would be in this case x squared plus y squared equals r squared, just like we talked about in a previous video. So now we would have 4 squared plus 5 squared equals r squared. So 4 squared, we would have 16 plus 25 equals r squared. And 16 and 25, that's going to be equal to 41. And now, because we're looking for r, we need to take the square root of both sides. And remember, if we take the square root here, this would technically be plus or minus. So therefore, r is equal to plus or minus the square root of 41. And one thing we want to realize is when we're talking about here this r value for, we can think of the hypotenuse or this radius of our circle, it's always going to be positive. So we're going to use the square root of 41. So r is always going to be positive. Okay, so now we know that here the radius of this circle is the square root of 41. And because up here we're looking for the exact values, we do not want to change that to a decimal and round. So now we have all the pieces we need for calculating our trig function. Because if you think of all the 6 trig functions, all we need to know is the x value, the y value, and the radius. So now if we're going to calculate the sine of our angle theta, we're simply then going to take our y value, which is 5, divided by the radius, which we just calculated to be the square root of 41. And that's it. There's your trig function. Or there's the sine of our angle. Now, if you notice, we don't even know what the angle is, but we were able to evaluate the sine of that particular angle just from knowing the location of the point 4, 5 and the radius r. And once again here, we would want to rationalize by multiplying by the square root of 41. And doing so, we would have the 5 square root of 41 over 41. So there's our exact answer. Now, of course, there may be some cases later on where they want an approximation, and you could certainly enter that into the calculator, but generally we want exact answers. So now if we go to calculate the cosine, well, the only difference now is we're looking at the x, so that would be 4. And now instead of, again, it's not the unit circle, whereas with the unit circle, this would simply be 4 over 1, or simply 4, but the radius here now is the square root of 41. And once again, we can rationalize by multiplying by the square root of 41 on top and bottom. So we end up with 4 square root of 41 over 41. And then, of course, from here we could calculate the tangent. And we know that the tangent, all we need to know is the x and y. So therefore, we're going to take our y divided by the x. So that would simply be 5 over 4. Okay, and then of course I'll quickly look at the other three here for this example, but if we wanted the cosecant, and again notice how I always go in order, sine, cosine, tangent, and then the cosecant, because I know that's going to be the reciprocal of what we had over here. And to make this easier, we could just look at this piece, because if we flip this piece, which is the 5 over square root of 41, that's going to already give us the correct form. Now, if we didn't have to calculate the sine function and all we were asked for is the cosecant, then we could certainly go up here and say, well, we know cosecant is going to be r over y, so the r is the square root of 41, and the y value is 5. So we could certainly do it that way as well. And the same thing would be true for secant. So instead of now for the cosine, which is x over r, the secant is r over x, so that would be the square root of 41 over 4. And once again, we can kind of compare it to this over here, 4 over square root of 41, so the secant is the square root of 41 over 4. And then, of course, the same would be true for the cotangent. So cotangent is x over y, so that means we would take 4 over 5. So there we have each of the 6 trig functions. All right, next I want to give you an example to see if you can work out. So we're going to do the same thing, except for now we have the point -12, -5. So you can stop the video and see if you can find, let's say at least the sine, the cosine, and the tangent. So to start off, if we're going to do this, I would still recommend drawing a sketch here of what we have. So a -12, -5. So we have -x, -y. So we're going to be in the third quadrant. So roughly, if we say this is -12, and then over here we'll say is -5. So that roughly puts us over here in the third quadrant. And here's the angle theta that we're talking about. And once again, now we have x and we have y. So now if we think of this as a right triangle here, then if this is, and I'm still going to use our signs here, this would be thought of as a -12, and we can think of this as a -5. Using Pythagorean Theorem again, we could take x squared, which would be -12 squared plus -5 squared equals the radius squared. So once again here we would get 144 plus 25 equals r squared. So r squared is equal to 169. And once again we'll take the square root, and that would be technically again plus or minus, but we know that we're looking at the positive. And here if we take the square root of 169, if you go to the calculator and we actually take the square root of 169, you're going to determine that's going to be a nice number, 13. So in this case, we would simplify this to a positive 13, and that's going to be our radius. So now we could easily go through and calculate what is the sine of the angle. Well, remember, sine is y over r, so our y value is -5. The r value is 13, so we have a -5 over 13. And then for the cosine function is x over r. So the x value is -12. So we would simply have -12 over 13. And then if we want to calculate the tangent of the angle, that's simply going to be y over x. So that would be -5 over -12. And keep in mind here, we have two negatives, so that would turn out to be a positive 5 over 12. So here we have the sine, cosine, and tangent. And of course, from here, you could actually calculate the other three by simply taking the reciprocal. All right, so let's try one more example. So just in case you didn't get that one, we can give this one a try. Let's say that I give you the coordinates of 1, -1, and you can try stop the video and try this one. So once again, I'm going to look at where 1, -1 is located. So we would go over +1 on the x-axis and down a -1 on the y-axis. So here's our point right here. So that gives us this particular angle here. And once again, we will think of this as our little right triangle here, so that we would have the side is 1, -1. So once again, we need to find the radius. So in this case, if we're trying to find the radius, then we could say that we would have, uh, let's see, 1 squared plus -1 squared. So that's x squared plus y squared equals r squared. So 1 squared is 1, -1 squared is 1. So therefore we end up with 2 equals r squared. And once again, to find r, we take the square root. And again, r has to be positive, so that tells us that r is equal to the square root of 2. Now, of course, we know that if you went to the calculator and we tried to take the square root of 2, we're going to end up with a decimal here. So we don't want to round this because, remember, we're looking for the exact answer. So we're going to leave this as the square root of 2. So here we have x, y, and over here we have our r value. So from here we could easily calculate the sine of theta now is the y coordinate, -1 over the r, which is square root of 2. And once again, we can rationalize by multiplying by the square root of 2. And we would get negative square root of 2 over 2. And then if we want to find the cosine of the angle, once again, we're simply going to take the x, which is 1 over r, 1 over the square root of 2. And by rationalizing once again, we would therefore end up with the square root of 2 over 2. And then for last, if we look at the tangent of our particular angle, that means we're going to take our y over x. So for that, we would simply have -1 over +1. So therefore, the tangent is equal to a -1.